to be taking a look at what comes after 3D or third dimension shape. Nowadays in physics they have the belief that we have other dimensions, things that we can't see that are interacting and forces that are interacting with the forces that we can see. A lot of times in geometry and in life we study patterns as well as opposites because they give you an idea of how things interact and how things relate. For example, in the 1800s, I believe they were theorizing positive and negative. Numbers exist, so maybe there's such a thing as an electron and a proton, things that react with opposites. So we're going to look at a simple pattern, very easy pattern, and kind of explore what comes after the third dimension. And then I'll put a video in the chat for a really interesting guy, Rob, who wrote a book and has some videos on YouTube about going up to the 10th dimension and how we could even possibly begin to imagine other dimensional shapes. One way that we might be able to do that began in the 1800s with the book called Flatland. And it's a very simple book, a very simple story about a land that's flat. Everything's two-dimensional. And so when you're looking at other shapes, all you see is really a straight line because you're a one-dimensional shape, like let's say a dot, or better yet, a square. If you're a square and you're going to draw a square on your paper, like this, and that was an actual living thing, and it was looking at a triangle, if it's looking this way, from the triangle's point of view, it only will see that line. Looking the other way, looking from the point of view of the square or rectangle, we're also only going to see a line. So it's little exercises like this that help you to see, well, what would a two-dimensional shape person's point of view be like, and how would they experience 3D? And from that, we can build as almost a metaphor for what it would be like to look at things in 4D. So let's look at the very easy pattern. We start with a point. Almost like in physics, some argue that one dimension could possibly be considered time, because you need to start with a time, or in shapes, we need to start with the place that you draw the shapes. A point really isn't a thing, it's more of pointing or a location. We're going to look at the dimensions, and we're going to look at how many of the previous item are being used to make the next shape. So we're going to begin with the first dimension, which would be like a length. A line is a one-dimensional shape, call that 1D. So when you're drawing on your paper with just straight flat lines, you'd be drawing one-dimensional shapes. How many of the previous things did we use to make it? Well, before the line we have a point, and we use 2 points to make that line. The next shape is two dimensions, so instead of just the length, you might have a length as well as a width, which would make something like a square. So how many of the previous shape did we use, or the previous thing did we use to make this square? And we use 1, 2, 3, 4. 4 lines to make a square. And we go to 3D, or a three-dimensional shape, and it would be something like a cube. A cube has length and width, but then it also has height, so it would be the same as the one before it, only it would go back in another dimension. So how many of the previous are used in order to make a cube? Well, how many squares we use if we unpack a cube, it kind of makes the top, the bottom, top, bottom, and then the 4 edges around the shape, the front, the back, the left, and the right. So really there are 6 squares being used to make a cube. If we were to continue this pattern, we can see what a 4D shape properties might have. So we don't know what it looks like. There are guesses. And really the shapes we see on the internet are technically not 4-dimensional. We'll explain that in a moment. But we can predict that they're going to be using 8 cubes. So if we can imagine a shape made out of 8 3-dimensional cubes that fit together in some way, and we could continue. 5-dimensional would be using then 10 of these shapes that we can't even really imagine. So it's pretty interesting. And then suddenly you're in this weird spiral of shapes and things that you cannot see. So what this 4D shape tends to be hypothesized that is a Tesseract. Now, even in the Marvel movies, you hear of the Tesseract. That's where Thanos gets his powers. Um, and what the So if you look at the word Tesseract, it's thinking of a 4D shape. So you can kind of see this shape here where there's a box, and then there's kind of like boxes going all the way around it. There's a box in the center with boxes going all the way around it. And the thing about the shape is that it folds into itself infinitely. So here's another example. That's the same one. Here's another one. This one's the more common used example. So why is this not 4D? Well, first of all, it's using 3-dimensional shapes, length, width, and height, on a 2-dimensional screen, a computer screen. So really it's not 4D, but our best representation of what a 4th-dimensional shape looks like. So could you imagine 10 of those put together? I mean, it hurts my brain to even begin to consider what that might look like. So the book was called Flatland. In the 1800s, they made a book that was showing what it would be like to live in a 2-dimensional world, and then using that metaphor to sort of try to conceptualize what it would be like as a 3D person or figure like we are, experiencing a 4th-dimensional shape. And there's even a film somebody made called Flatland the Film, and the person who wrote a book and has YouTube videos about imagining up to the 10th dimension in physics is Rob. So I'll put these links in the video, and I hope that you one day can explain to me what it looks like and where we go from here. Because I think we're getting better and better where the young people today are going to be going back to their teachers and explaining all of the amazing, wonderful, amazing things they're learning that we just had no clue about when we were growing up. So that's the idea of what the 4th dimension, in theory, might look like, or the properties it might